In the second part of this series on proportion confidence levels, what I'm going to do is I'm actually going to calculate the proportions. And I'm going to use three formulas. The confidence interval, obviously, is p hat. Sometimes you'll see it p bar plus the margin of error. And we know that the margin of error is z asterisk. Sometimes you'll see this as z sub alpha over 2, and that's to remind you to cut that error in half as you're creating the interval itself times the standard error of the probability or of the proportion. And the standard error of that proportion is the probability of p times 1 minus p over n. And to kind of put into perspective what we're doing here, right? And it'll take off for artistic ability or lack thereof, including my own, is we are creating this confidence interval at a 95.44. But as with any confidence level, you always have some form of error, okay? And that's what we're going to have to determine in order to come up with the actual confidence level associated with the 95.44 confidence level. And how do we do that? Well, I'm going to go to a different piece of paper here. And so if we know that the confidence interval is, as I discussed, the confidence interval is equal to p hat or p bar plus the margin of error, and the margin of error is equal to z asterisk times the standard error for p hat. Okay. All we have to do is kind of find these two values in here, because we already know what p hat is, which is 0.2, correct? And we're trying to solve for the confidence interval. So z asterisk, to come up with that, or z sub alpha over 2, is we knew from the problem that we were doing this as a 95.44 confidence level. So we go 1 minus 0.9544, which is equal to 0.0456. Now, if you take and divide that by 2, because keep in mind we're talking about an interval, so that's why we have to consider both sides of the tail in the analysis. So we're going to divide that by 2, and that will yield a 0.0028. So I'm going to use the z-table. So in order to use the z-table, I need to subtract 1 minus 0.0028. I'm going to use a positive z-table, and that's going to equal 0.9772. And so we're going to come in here, and then we're going to run the z-table. It's a reverse lookup. Here's a point. We kind of go in here, and we look at all the values, and you have 0.9772 right here. And so the value for z asterisk, the critical value, or z sub alpha over 2, is equal to 2.0 exactly. Now the second part of this, so we know this already. We know p. So now all we got to do is find that standard error. And to determine the standard error, the standard error for p hat is equal to the square root of p times q over n. We know that the value of p and q just because it was 0.2, and then 1 minus 0.2 is 0.8, and then we know n was 100. So if we just run this out, 0.2 times 0.8, 0.2 times 0.8 divided by 100, and then we square root that. And if you run that out, you will get a value of 0.04. So now we have pretty much everything, okay, 0.04, 0.2 times 0.8. So now we have everything we need to determine what that confidence interval is. So the confidence interval is equal to p hat, which is 0.2, plus or minus z plus or minus z asterisk, which we determined was 2, times 0.04, which was the standard error for the proportion. So that's equal to 0.2, 0.2 plus or minus 0.08. And so we know that our margin of error and the associated confidence interval is going to be 0.2 plus 0.08, which is 0.28. And on the negative side, it's going to be not negative 0.12, it's just going to be 0.12. 0.12. And that comprises our confidence interval at a confidence level of 95.44, in which p hat is 0.2.